and welcome to the ARK CLS BizTalk session. I hope you will enjoy the next 15 to 20 minutes. If you have any questions, please go to our booth where there is someone there ready to answer them. During this session, our Managing Director, Adrian Benetton, will say a few words. Then we'll have a short presentation by Ellen Bonshaw-Mays, who will introduce you to our new GeoDataSync Framework. Finally, we'll hand over to Julian Moore from Applied Petroleum Technology, who will talk about their gas interpretation and reservoir analysis software tool. This new application was developed by ARK CLS under contract to APT. So, let's get going, as we have much to cover. Over to you, Adrian.
Thank you, Sarah. And hello. Well, what a year. Attending the EAGE as a virtual exhibitor was not in our plan. We wanted to celebrate our 20th year with our clients and all the attendees in person. However, here we are, and I have news for you. This year, we launched GeoDataSync Framework, which includes Develop and Deploy. You will hear more about this exciting technology from Ellen. We knew we were onto a winner when we saw license of this tool faster than any other ARK CLS product. We're still only at the beginning of what will be possible with this technology. By design, GeoDataSync can be configured to do many different things. It will be the backbone of all future ARK CLS application software development. It is being used and will be used by geoscientists and other engineers to connect MATLAB and Python live to interpretation systems. It facilitates third-party software development companies to connect their own software to these core systems. An example is the new rock physics tool called CENTER by Rock Physics Technology, who are using our GeoDataSync framework to connect live with Petrel. GeoDataSync will help ARK CLS deliver our bespoke software development services faster than ever before. An example here is Girasol, which we developed for Applied Petroleum Technology. You'll hear more about Girasol in Julian Moore's talk. Our GeoDataSync framework improves speed, connectivity, and workflow efficiency. 2020 will be remembered for something we'd rather forget. But now we can look forward to 2021 with renewed vigor. As a solutions company in this digital age, we are very excited about our future development and welcome your inquiries. We look forward to seeing you all again soon. Thank you very much.
Yes, we're all hoping 2021 will be much better. We are now going to hear from Ellen, who will talk about the ARK CLS GeoDataSync Framework. This is an exciting development which is already delivering great benefits for those early adopters and promises much more in the future.
Thank you for the introduction, Sarah. My name is Ellen Bonshaw-Mays, a geoscientist at ARK CLS. I'd like to take this opportunity today to demonstrate to you how our new cutting-edge GeoDataSync Framework software can be used to enhance the efficiency of your workflow. Let's take a look at the current workflow within the upstream sector. Currently, there is an apparent lack of interactivity between powerful tools such as MATLAB and Python and geological interpretation systems such as Petrel. Of course, this could be other interpretation systems such as OpenDetect, Kingdom, or Decision Space. The clock starts ticking as soon as the data exchange process begins. You first have to interact with the data in the chosen interpretation system. To have an algorithm in MATLAB or Python operate on your data, you have to export the data from the interpretation system into an intermediate file format such as SegY. The SegY file then gets imported into either MATLAB or Python, where your proprietary operations and algorithms can be applied. This freshly manipulated data then once again has to be exported into an intermediate file structure, and then imported back to the interpretation system. This is quite clearly a lengthy, time-consuming process. Excess time is being spent on the data exchange processes, which could otherwise be spent on more beneficial tasks. So, what changes do we want to see? With the current workflow, as previously discussed, there is an apparent disconnect between these powerful tools and interpretation platforms. Here at ARK CLS, we envisage a more connected, integrated energy sector, with our GeoDataSync framework being the main driver behind this. We want to exploit platforms such as MATLAB and Python in such a way that the unique abilities of numerous interpretive software can be taken advantage of simultaneously. This involves connecting MATLAB or Python directly to the chosen interpretation software, amending code, and utilizing especially curated functions to interact with the geological data, which can be viewed in real time within a window of the interpretation platform. There are two variants which exist under the GeoDataSync framework. We have GeoDataSync Develop and GeoDataSync Deploy. Develop allows geoscientists and engineers within a client organization to develop apps and utilities within MATLAB or Python live with a core system, in this case, Petrel. Establishing connectivity through a live GeoDataSync server allows real-time operations to be performed in a live coding environment, using data obtained from Petrel via the rich set of GeoDataSync GET action functions. Once the data has entered the coding environment, various proprietary algorithms and functions can now be applied to enhance the data. Finally, any new data generated can be written back to Petrel using the GeoDataSync create and put action functions. Let me now demonstrate with an example how easy it can be to use GeoDataSync Develop. I'll use MATLAB with Petrel, but this could be demonstrated in a similar way using Python. We provide free training to get you going, even when evaluating. Firstly, we need to launch Petrel in the usual manner. Once the project has been loaded, under the Seismic Interpretation tab, we will see the GeoDataSync Develop icon. If we click on this icon, we will pop up the GeoDataSync Develop dialog. The status initially will show Not Connected. Clicking the Launch Server button will start the GeoDataSync Server plugin for Petrel. You will see a port number being displayed. This will be needed to establish a connection between MATLAB and Petrel. On clicking this button, the status changes to Waiting for Client. We must now go to MATLAB. Within MATLAB, if we place the port number in this command, we will get the server object returned. We will also see the status change to Connected to Client. This server object will be used in all GeoDataSync MATLAB functions. Here, we are requesting a list of 3D seismic cubes from the current Petrel project. In this line, we request the geometry information for a chosen seismic 3D cube. The final GeoDataSync function requests the seismic line from the first cube. This returns an object with seismic data for either an inline or a cross line. We can then manipulate this 3D seismic line in MATLAB. With just a few more MATLAB commands, we can display the seismic data retrieved from Petrel. We can observe it is the same data shown with a different color map by viewing the same data in Petrel. This is one example of accessing 3D seismic data. Other data objects can be operated on in a similar manner. If you pop over to our booth, we'll happily demonstrate the range of capabilities GeoDataSync Develop has to offer. We wanted to give geoscientists and engineers within an organization the ability to roll out their in-house developed MATLAB or Python apps to asset teams in the form of a fully developed compiled plugin to the core system. Not every geoscientist has a leaning towards coding. While source code can be protected, we thought it would be better to provide a facility where in-house developed MATLAB or Python apps could be compiled. Such compiled apps are more efficient, can't be tampered with, and connect to the core systems using GeoDataSync Deploy. ARK CLS configures GeoDataSync Deploy for each licensee, which protects the licensee's in-house developed GeoDataSync-enabled applications because such apps will only run on the licensee's specifically configured GeoDataSync Deploy. Following rollout of in-house developed apps, the developing geoscientist or engineer can continue the development of these apps with future enhancements. So, where do we see this enhanced connectivity steering the energy sector towards in the future? The great flexibility of coding languages opens the door to a range of possibilities and, consequently, does not solely limit the GeoDataSync framework to just Petrel. In 2021, ARK CLS plans to release an OpenDTEC GeoDataSync server. We are also very likely to add an OpenWorks GeoDataSync server. We could also develop a GeoDataSync server for Geolog, or a server to work with a proprietary oil company developed core system. Other servers could include Decision Space and Kingdom. As the energy sector moves towards web-based storage, such as the cloud, GeoDataSync can adapt and mold to these new technologies accordingly. If you have any questions, please drop by the ARK CLS booth here at the EAGE, either now or anytime this week, where we can answer questions not only about the GeoDataSync framework, but also about any of our other ARK CLS software products or services. Thank you for listening to this portion of our BizTalk presentation.
Thanks, Ellen. I think I learned something. Ellen is at our booth ready to answer questions. Now for our guest speaker, Julian from Applied Petroleum Technology, who will talk a little about the new application called Girasol. ARK CLS developed this software under contract.
Hi, my name is Julian Moore. I'm the Managing Director of APT UK and the co-developer of the Girasol well site gas interpretation software. This software has been developed in partnership with Tim Dodd, who is an ex-colleague from BP, and the software company ARK CLS. Today we're going to give a presentation overviewing this software. Girasol, which is a simple tool for the processing, display and interpretation of well site gas data. The approach involves a normalization function which removes the influence of drilling parameters and several QA/QC steps to provide an easy-to-use application designed to be used by a broad range of geoscientists. The method which we've developed allows you to do a rapid evaluation of well site gas data in either legacy or current wells, and it gives you a quantification of the distribution of pay in a well and the phase of the petroleum within the pay zones. It maximizes the value of the gas data you collected and acts as a point of integration across the operational team and either the exploration or the development team. Additional benefits potentially include the ability to reduce data acquisition costs in development settings where you're drilling infill wells. Also allows you to potentially select zones for sampling if you're using downhole sampling tools, for example, and potentially allows you to select zones for fracking if you're working in an unconventional setting. So while well site gas data certainly isn't a new technique, it's somewhat underutilized in the industry, and there's no tools at the moment that allow you to do what Girasol does. The data is collected in every well drilled, so it's a safety requirement, so the data itself should be ubiquitous. The data takes the form of both the total gas, it's usually the total combustible gas, and the compositional data from the GC, and we can convert the GC data into a total gas equivalent and then compare the two to act as a QA/QC method. It provides an independent view on the fluid fill of the sections that have been penetrated. So when I say independent, I mean independent from petrophysics. There's no assumption around RW, and so it can be a more robust method for making those sorts of evaluations. It also gives you a direct indication on the phase where data is of reasonable quality. So as I mentioned, the principal application is to give you a quantification of the distribution of pay within a well and the phase within that pay. You already collect the data because it's a safety requirement, and it gives you an independent view from your petrophysical evaluation. So it's a very useful method to integrate and supplement your petrophysical data. Many wells now are just drilled with logging while drilling, and that data can be of variable quality. As I mentioned, the method first normalizes the gas data to remove the influence of the drilling parameters. If an oil-based mud has been used, we have a method to correct the gas composition for the use of that oil-based mud. The heavier compounds will partition into the oil phase when an oil-based mud has been used, and therefore the collected data will be drier than it should be, which will give you an incorrect phase evaluation potentially. So we've created some correction factors based on a literature review, but we allow the user to edit those correction factors at any point in time. So either when they start the evaluation or once they've got the software and evaluation set up. So you can calibrate your gas composition data to any available calibration data, perhaps from PVT experiments, for example. We can also have the ability to filter out connection gases, so you're only looking at formation gases, and you can remove the influence of non-formation gases as well. In the pictures beneath, we just got some screenshots from the software. So there's a main gas track, which is your principal interpretational tool. We can load in 2 different petrophysical logs. Usually we use a gamma ray and a deep resistivity. You can plot all the sort of standard gas interpretational plots, such as Whittaker plots. Pixel plots are very interactive, so you can plot on a depth interval on the gas track, and that depth point will then be presented in the pixel plot, and it's very easy to then add and remove data depth points. We've also developed some bespoke plots within Girasol. We've used a large PVT database to create plots that allow you to cross-plot either the C1 or the C3 ratio, and that's the ratio of the gas from the C1 to the C5 gases, against GOR. And obviously the GOR is the determinant of the phase state, which is coloured in the background. So in terms of the evaluations we've run so far, Girasol was released in the beginning of 2020, and we've predominantly looked at wells in the North Sea and the west of Shetland. The west of Shetland was particularly interesting because it has some atypical reservoir types, such as fractured basements and volcanoclastic reservoirs, which are challenging petrophysically. And so we've been able to use Girasol to give a different way of looking at the evaluation of those reservoir types. We've also looked at examples from the Paleozoic from the onshore UK, and wells from Alaska, the Permian Basin onshore US, the Barents Sea, the United Arab Emirates, and from Egypt. Here's an example of an evaluation from the Quad 21 in the UK sector. This well is an interesting well. It's a 2-phase accumulation in good quality Albion Kopovic sands. The data, so post well, or the well was sampled on MDT, which proved a water leg, an oil leg, and a gas leg within the reservoir. And the evaluation on Girasol picked that out very nicely, and we'd be happy to give you a demonstration of that if you wish. The oil leg had a GOR of around about 1,000 scuffs per barrel, and that's exactly what we predicted from our C1 versus GOR plot. And then the gas leg had a CGR of around about 83, which is also what we predicted. And there's a summary of the well result. In summary, so we've developed the software with ARK CLS, who are an ocean-proof vendor. So the package is available either as a standalone app or as a Patrol plugin. The licenses are available in 3 formats. Principally, a perpetual license with a maintenance fee is our preferred route. We do shorter term licenses, either 12 months or through independent consultants. We provide a single month license. We're currently developing the ability to use multiple background gas values, and that will be available by the end of the year. We're also looking at developing things like integrating pressure data and multi-well correlation, which will come at a later date. Thank you for your attention today. If you have any interest in APT or the Girasol software, please get in contact. You can reach us via ARK CLS, via LinkedIn, or via our webpage, apt.int.com. Thank you.
Thanks, Julian. That was interesting. We wish you luck in promoting this unique technology, and we look forward to continuing working with APT in 2021 and beyond. That's it, folks. If you have any questions about this session or any of our CLS software or services, please pop into our booth where there will be someone there to answer all your questions. Thank you for attending, and we hope to see you all again soon.